Okay, so the derivative. Let me write something up here. Let's see if you can figure this out. So f of x is x squared. The derivative. Anybody have this memorized yet?
What you waited. F is f plus h f of minus a f of x over x. 3x plus h.
I put x in.
Oh, okay.
Okay, does anyone know the answer?
Is this where you can substitute real quick?
Yeah, you know what? How do I know that? Without even doing the algebra.
I really have no idea.
Do you notice the relationship between those two items?
Can you just put the x
Okay, that would be one part of it. But then I can throw this at you.
So, can you just tell us it and then try to figure out how you got there?
No, allow me to use a nail and a hammer. So, is there a relationship between those two items? Does that work every time? I don't. Does it work every time? So far.
Sure does.
So far. Does
You put the
that work here, right?
you put the x on in front and then decrease.
How about-
Oh my God.
Does it work for that one?
Yes. Is that how it works?
This is called the power rule.
I love it.
What about with so take the exponent, put it out front, and subtract 1. That's called the power rule. Now, do we have to mess with algebra anymore? We don't have to worry about it. We have to, I told you last time, we have to be able to do some stuff like this. It's very easy.
You can take it up a high bar, like what if there's a square?
Yeah, let's see the equation. We'll get there. Relax here. Okay. So, here's how your boat puts it. If that is your function, the derivative, bring the exponent out front and subtract 1. This is the more formal way to write it. And I need to expose you to that so you're ready for it in the future, okay? Next.
What is it to put in?
We will get there. This is an equation, by the way.
Yeah, I meant like x squared plus like 4x.
Making our life difficult.
Yeah, can you just be happy for that?
I can't anymore because I know that's coming.
What's the derivative of that function? You're close. 2x, yeah? What's the derivative of that?
1.
Yeah, because it's x to the 0 now, correct?
Would be 1.
No, it's 0.
Yeah,
Constants
it goes
are
down.
here. Constants
It go away.
is here.
Well, that's really. I like when you do it.
There you go. So even if it is to the power of 1, like the power of 0, you wouldn't get 1 to the power of -1. Nope. You gotta think of it in terms of slope. What is the slope of a line y equals 1? 0. So the derivative is 0. Right? It's just a flat line with slope 0. The slope is 0. That's our value for the derivative. It becomes 0. Okay? That's how you got to think of this stuff in terms of slope. So what is j prime at 2? 0.
X squared?
Yeah, 2 times 2.
Oh, you're saying that. Okay, yeah.
No, it's the same one. J prime at 2 is 5. Yeah, so write an equation for the tangent line 2j of x at x equals 2. This would be, I could probably make a z like this. And we have done all of the background work, right? We just need a point. We need j prime at 2 is 5. We need, what is j of 2? Right? Or in the original. We have a point and we have a slope. Can we write a linear equation? Done. Don't simplify it if it's a free response. If it's a multiple choice, you might have to do some algebra. But then the answers are there, so you should be able to get the right alphabet. So, how good? I like it. There are a couple of notational things that I need to show you. You can write this right here, j prime of x, you can write it 3 different ways. So, I want to show those to you because you can see it. We found this is true, right? We could also write I could also say this is the original, right? You could write y prime. That's another way to write it. J prime, y prime, they don't have the prime in there, they're both derivatives. This is the one that kind of goes with this. You can also write it like this. We need this notation later, so get used to using it. This is the derivative of y with respect to x.
Is that dx?
Yeah. Derivative of y with respect to x. We need this again for later work, so be able to use it. You can also write this one derivative of j, dj dx. And this one could also be written like this. What the important part is you're referencing the j or the y right there. And the x has to be this in this function here. Okay. be aware of those notational differences there. It's called Leibniz notation. You guys don't need to worry about that, but this man in Leibniz is pretty smart, and he thought that we needed a different notation. And it proves useful. Okay. You remember the function u dx. Does anybody know the derivative of u dx? X e x minus 1? No. I'm not doing it. Okay, the x is in the exponent, so we cannot use the power rule. So keep that in mind. The power rule only applies when x is a variable in the base. Okay? I will give you ways to deal with that too. Don't worry. The derivative is, ready? Yes. Just the way it works. Trust me when I say that's the way it works. I can show you the proof, yeah. It's just, E is in that sweet spot where it's under the, that's all I can tell you right now. There are a whole 3 pages on it if you want to look it up, but just be aware that this is the case. Make sure that covered it all. This is why calculus gets easier. Because of this kind of stuff. So let me make sure about that. Here's a way you might be presented with. This is a way to be asked about the derivative. This is the derivative with respect to x. Notice there's no f or y or anything, because there's no y equals or f of x equals. Same thing. Okay, same thing.
Oh. Remember, because it's a factor.
So, wait, if you wanted to write it like that, so it'd be like, derivative with respect to x. If you have it like parentheses, x cubed, then that equal, x plus 3x.
That is what you just said. You might also, let me give you something like this. We might say calculate df dx at x equals 2. This is saying the same thing as find f prime at 2.
Oh, okay.
Those are the same thing. This bar means evaluated at 2. They mean the same thing. So be aware of that notational difference. What is the derivative of that function?
Why should I put that?
It's a function.
Oh, that's just.
It's just a function of the second problem.
Oh, all right.
That's how they get the derivative. Bring the 2 down. 3 times 2 is 6. Subtract 1. And then the derivative of 2x. So if you get a number in front here, just multiply it when you bring it down.
So you can look at it in like two, every time I get a problem, and you
That's exactly what we're doing. It's one of the rules your book puts out formally. So what is this evaluated to? So you would write this, df dx at x equals 2 is what? You guys know that one? This is x to the first. 1 minus 1 is 0. X is 0 is 1. I think we've covered just about everything. You might see something I haven't shown you. You gotta be a thinker. Okay. We're gonna do the rest of the section tomorrow, so if you run into something you just absolutely do not recognize, just take it out. Alright. Yeah. How a little bit better than algebra, right? These are very selected. I chose them purposely, so we gotta write every day's problem. I am still going to ask you to do some of those calculation problems. It's more for the algebra practice than anything. We need it. I cut off a couple problems from that because it's due tomorrow, and I'm not kidding you. So if you log on to the classroom, and Google Classroom, there's probably more than this on it. This is all that has to be due. It looks like a lot, but again, we listed everyone separately. So 20 minutes, take advantage of it. Let me know if you have any questions.
Well, I did move the classroom. Fine. I went to my email. Take care of that.